All right, so at this point, hopefully you had a chance to try this practice. So this first one, I rearranged it to be in standard form. Negative 2x to the fifth minus 2x squared plus 7. Now it is going in descending order. And then using the notes that we did yesterday, we know that if it has a 5 as a degree, then it is what we call a quintic. And then I just count the number of terms. I have 2x to the negative 2x to the fifth, negative 2x squared, and 7. So that is 3 separate terms. So therefore, it is a trinomial. Then for the leading coefficient is the number in front of the variable with the highest exponent. So therefore, it is the negative 2. And when it's in standard form, it's easy to see because it's the first number there. Then it asks me the maximum number of U-turns. So you have to remember that it's always a degree minus 1 for the maximum. So that's where I got 4. And then using what you learned today, you're going to combine the leading coefficient and the degree to tell you the end behavior. So I see that the leading coefficient is negative 2. So since it's negative, I know I'm going to be going down on the right. So I fill in the right one first. And since I know that it is a quintic polynomial, that means that it is odd because 5 is an odd number. So odds always go the opposite way. So that is why this one is going to end up having an up-down end behavior. For 7, it's constant and it is a monomial, meaning it just has one term. Therefore, it doesn't have a leading coefficient. It can't have any U-turns. And it doesn't really have any end behavior. The graph just goes from side to side depending on if it's x equals or y equals. Here is another monomial. It is quartic this time. And because 6 is a positive number, I know it goes up on the right. And because I know 4 is an even number, I know that they're going to match. So remember, evens match, odds don't. Here we have another positive number of 5. So that's why it's up on the right. And then 2 is even, so they match. And that is a quadratic monomial. If I keep going down, I have a couple more even, so let's go to another one. All right, this one. This is a trinomial. There are 1, 2, 3 terms, and it is again quintic because it has a degree of 5. So my leading term is 5, which is positive, so I know it's going to go up on the right. But since my degree is also 5, that is an odd number, it goes down on the left. So they do not match. Here's another example of up when it's even. So now I have this negative 2x cubed. It is a cubic function because it's to the third power. It's a monomial because there's only one term here. Negative 2x cubed is one term. The leading coefficient, the number in front of the variable, is negative 2. Since negative 2 is a negative number, I know that my end behavior is going to go down on the right. Then I go back and look at this, and my degree is 3. 3 is an odd number. So since it's an odd number, I know that the end behaviors are not going to go the same direction. So since I already determined that it's going to go down on the right, it automatically is going to go up on the left. There's another example of an up, where it's positive and even. Here's another positive and even, up. So now I have a positive 12 and an odd 3. So positive and then odd tells me it's going to go up on the right, down on the left. So this would be a down, up. Here's another example of down, up, and it's because I have a positive 1 as my leading coefficient and a positive 1 as my degree. Here's an example of down, down. Yes, I have an even function, so they're going to head the same direction, but my leading coefficient is negative. So if the 1 on the right goes down and it's even, they both have to go down. So that is an example of down, down. And I encourage you to pause this video and just check and see if you got anything wrong. I'm actually going to scroll back up real quick because I missed something. So there are a couple ones here like number 4 and number 7 that you actually need to do a little bit of work before you even put it in this chart. This is 7x squared and this is 2x squared. So we know from multiplying and factoring that these are what we call like terms. So if they're like terms, we can combine them. 7x squared minus 2x squared is going to give us 5x squared. That is nothing new. We already know how to do that. So that's where I got 5x squared from here. Same for number 7. This is a negative 6x squared and a positive 9x squared. 9 minus 6 gives me 3. So that's where I got 3x squared. Similarly for number 11, 9x to the third power, or otherwise known as 9x cubed, plus 3x cubed, they both have the same variable, which means they are like terms. So that's where I got 12x cubed from. Oh, I did not fill this one in. This is a binomial. I'm just going to write dot, dot, dot. My pen decided that, I think it's because I'm recording too much, the screen is going very slow. So after this, I just wrote dot, 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 but you should know it's binomial, trinomial, monomial. It's always nomial afterwards. So that is the rest of it. If we're looking at number 18, negative 8, that is an example of a constant monomial. Again, there isn't a leading term because there's no variable and it doesn't have any U-turns. We don't want to call it 0 U-turns, it just doesn't have any at all. And this is an example of what it might look like on the graph, going through negative 8 either on the X or the Y. All right, and that is the practice worksheet.